Welcome back to the lab. So we're quickly going to talk through two different things. It's considerably easy because we've done most of it already. So you essentially, if we are just knitting this quickly, the help does not exist. If it does exist. Okay, let's make sure that you now it's routing to the same directory. So this is the actual lab, but it's basically it's straightforward what is being asked from you. So it's basically the same thing as we did already. So you clean your environment here. Here's the setup. That's a Word document. So we are setting a Word document. Library Haven, we know already. We're loading the DIT file. We're coming to summary CSD. It's a summary file. Here we have medians, means, standard deviations. Again, we know how to look at this. We know how to create our okay. Don't be discouraged by warnings like that. Just zoom the whole thing out. That should at one point allow for you to maybe not. Then just export it as a PDF. What is this? No, it doesn't like it. So you can always kind of, with the PDF function, you can always plot in the actual working directory. You essentially, I think you've seen that, right? Whenever you do this, you need to close it with device off. Yeah. With device off, you're basically powering off the PDF core engine, the graph core engine. I haven't shared the screen, sorry for that. So you had to look at me while I was trying to kind of, okay, so I went through this set working directory, we know, library Haven, we know the descriptives. And now here I've implemented now PDF histogram, and now the histograms. And I am now implementing this and this, and also take the density plots in there. So you can just expand that, right? Device off. What's important is that you are consistent with the PDF histogram will allow to put a histogram in your working directory. Just make sure you define the working directory first, otherwise you're never going to find it again. That's usually what happens to most people when they start off using this function. So here, 2 PDFs now. So you created now PDFs using these histograms. So that's an elegant way to do that. You can also pack the box plots in there. Let's do this since we already added. Okay. So here we do this now. Okay. So now we have the box plots in the same PDF too. Okay. So here we have the comparison between D-test and age. There is the same error that I pointed out in the lab already. So please replace this with a tilde. So now that it's 35, 36. So here's the fit. So here we have this. Here we have the fits with the additional factors. This is now the production of the propensity scores. This is the logistic regression. And this here is the predicament. Okay, so we see here now, if we are using now this MPS and we're predicting this, we're getting 453 entries. So this is all our predicts, right? So we're creating here now the propensity score data frame contains propensity scores for all individuals and homelessness from the MP. There's something else. MPS model homeless. Okay, that's interesting. Like as a table code. Okay. Okay. So we're getting this from the MPS file. We're getting MPS model and homeless. So here we get the actually used homeless data. We can match this now up, and now the region of common support. We're getting library, we're getting labs, and now we're getting mutate homeless. If else homeless equals 1, labs 1 is now so labs 1 is homeless status yes. So this is the criterion, right? Labs 2 is now yes and no. It's homeless status no. So we are matching together now. That's interesting. Okay. So labs, this is how labs look like. So we have having a homeless yes and a homeless no. And we're basically if elsing yes and no. And by that we essentially get homeless as a oops. So we get homeless with an if else. As an if else coded variable. We're doing now mutate ggplot doing press. So what we're getting here is this now. Where's this coming from? Hold on a second. This is PRDF. It comes from PRDF. PRDF. That's one. PRDF. Homeless. PRDF. Not found. PRS. Oh, good. PRS DF. Okay, so we're getting PRS the homeless. So if we're just taking this, and this is nice because with this if else, you essentially can PRS DF underline DF. Darn it, this okay, homeless not found. PRS DF. All right, good. So Okay, so this if else is now recoding. Homeless equals 1 to lab 1, and lab 1 is homeless. Yes, right? Okay, so this is how the if else is being used here. In essence, what it does, it creates a ggplot with using bins equals start bins, using bins equals yes, okay. Okay. So this is now essentially what the outcome of this will be. You have this in the probability of being homeless. You're basically getting here this histogram plotted. You have homelessness status, and you have the count of that probability. You can either do this with the histogram function. So this is our PR score. You can do this with the histogram function, or you can do this with another histogram function. Then with match it, you essentially you can rerun the matching. You get by that, you get your mod match is here essentially that no miss. This is basically where you do not remove any individuals. You get with mod match, you get essentially your match it object, which you can now investigate. It doesn't show me any more plots. What is going on here? Okay, just a second. Okay. So now, whenever something doesn't work in our studio with the plotting, or kind of restart our studio, that's what I did now. So essentially, this is now the histogram that we have coded here in the ggplot code. Now we are rerunning our mode match, and that now miss. We get now plots of this, where we basically see here the QQ plots through which we can click, and we're seeing here matched versus OR, and we see to some extent how they would start to align each other a little more, and it would basically take effect on the propensity score balanced matching. We also see now that when we actually use match data, we get here to a data M file that is 418 observation only. And And here we can do visual inspection again. This is just like was shown in the lab. So this is now the visual inspection of, that's a little bit too large as a PC. Okay. So just it's a little smaller. So I'm dropping it for now. So essentially you're seeing here the same, you can with CEX, you can change the size of this legend. So you see basically the same plot that we have seen in the lecture. And then we can also analyze the differences in the means by essentially calculating these differences from our data file data in DTAM. All right, hopefully this was helpful. Good luck with the lab assignment. It's again, it's considerably simple. You are just asked to use different variables and no, not this one. What is this? So you essentially just need different covariates, and you're also doing the same exercises that we did just now. All right, good luck. Let me know if questions. Let's have a conversation on the discussion board if that's necessary. Let me know how things go. All right, good luck. See you next week. Bye-bye.